Hello, everyone. Good morning, or good afternoon, or good evening, depending on where you're connecting today. And welcome to this new webinar session, Rethinking Batteries, Exploring Batteries' Role in the Long-Duration Energy Storage Landscape. My name is Christina Galan from RedMat Events, and I will be today doing the housekeeping rules because today we have a much better moderator than I am. So today is it's going to be a good webinar. Just before we start, a couple of housekeeping rules, as I said, for your information. So this webinar will last an hour approximately, and the recordings will be shared in a couple of days. So you will receive this recording in your emails. Also, if you are connecting from YouTube, you have a chat available to introduce yourselves, let us know a little bit about you and why you're interested in this webinar. And also for any questions you may have, our technical team, Maria, is behind, and she will be sending it to us. If you're connecting from Zoom, you have a chat also available. So please, we highly encourage you to let us know where you're coming from, why you're interested in this webinar, so also the speakers can see. And if you have any specific questions for the speakers, you have a specific Q&A box for them to check the questions during the webinar, the presentation. So we are going to have a series of presentations, and then we are going to move on to a Q&A led by our moderator, Sherif, who will be introducing himself in quite a bit. And that's it. Also, if you want to know more, this is a session of webinars that we have to promote our RedMat event, specifically focused on long-duration energy storage that will take place on the 25th and 26th of September in Washington, D.C. So we'll leave a link in the chat if you're interested in knowing more. I'll be here during the whole session, so happy to answer any questions you might have. So without further ado, let's meet our speakers for today. Let's start with our moderator, Sherif from Storlytics. He will be joining the event. So Sherif, good morning for you. Let us.
Hey, good morning, Christina. Yeah, go ahead.
No, just want to give you the welcoming and really, really happy to have you here. And just if you could tell us a little bit about yourself.
Sure. So first of all, appreciate the invitation. So my name is Sherif Abdelrazek, co-founding CEO of Storlytics Energy Storage. We are an energy storage company that focuses on developing and providing energy storage project design software, much like or widely known as kind of the PV-Syst of energy storage. We also provide energy storage project development and design services. So again, thanks for having me and looking forward to the discussion.
Thanks, Sherif. Happy to have you. We also have Caroline Brannock from BASF. She is Senior Battery Technology Sales Manager, and we're very happy to have you again, Caroline. Welcome.
Yeah, I feel like a repeating champion on Jeopardy or something, right? So it's awesome. Thank you for having me back. It is a pleasure, as well as what Sherif said, to be here today. Really excited to talk about this topic and to be included on a webinar about long duration energy storage. I've been with the BASF about 12 years and representing the NAS battery team, sodium sulfur batteries. So I'm excited to talk to you.
Thanks, Caroline. We also have with us today Alyssa McQuilling from the Consortium for Battery Innovation. So Alyssa, I have you right there. I didn't see you for a second. I got scared. Hi, welcome, Alyssa. How are you?
Hi, thanks so much for having me. I'm Alyssa McQuilling. I'm from the Consortium for Battery Innovation. I'm the Research and Innovation Manager, so I focus on helping our members and partnering with national labs and other organizations to do battery research, specifically lead battery research. And I have a background in kind of air quality modeling and energy storage. So it's great to join you guys today.
Thanks, Alyssa. Happy to have you. And last but certainly not least, we have Brett Simon, Director of Commercial Strategy at e-Zinc. So good morning for you, right, Brett? You're based in the US.
Yeah, technically good afternoon, because it's just past noon. But yes, thank you. Happy to be here. My name is Brett Simon, Director of Commercial Strategy at e-Zinc. We are a long duration zinc-based battery company. I've been in this role for a little under a year and a half, but I've been in this industry for almost a decade, including a background in commercial strategy at other energy storage firms, as well as third-party market analysis and consulting.
Thank you, Brett. Yeah, I get my times mixed up. There's too many time zones.
It gets
in the
very
world.
confusing very quickly, especially when Europe and the US have different times for daylight savings.
True, very true. Well, thank you so much, Brett, for joining us today. And without further ado, I think we can start with the presentations. I'm going to stop sharing so Caroline can share her screen. In the meantime, I see that people are already starting to ask in the Q&A box, so that's fantastic. And we also have people from Chile, from California, from Spain as well. So we have a very varied group, which that makes it more interesting. So Caroline, I see that your slides are well. We can hear you, we can see you perfectly. So the floor is yours.
All right, thank you so much. I really appreciate it. So, like I said, I think we're having a great turnout today. So thank you so much for taking your lunch hour here in the US to be with us. Why do you care about, me being here? What can I share with you? Hopefully something about, how sodium sulfur batteries are fitting into this long duration landscape and the battery world. Really excited to talk about it. So let's just jump into it. Some of you may be familiar with BASF. Why is BASF here as a chemical company on the side of an energy storage webinar? What are we doing here? Well, BASF is interested in energy storage because we have very aggressive decarbonization goals as a manufacturing company. Not only do we have these aggressive targets, but our 80,000 customers worldwide also have targets, and we want to help them achieve them as well. So what does this look like, right? If we're trying to reduce our energy storage or our decarbonization footprint by 2030, we're doing this by 25%. By 2050, we are hoping to achieve net zero, right? And we know that there are lots of factors that will contribute to that. Some of them are transitioning from gray infrastructure over to green. Some are utilizing new technologies, right? So like the energy storage sectors, right? So how do we incorporate that into our continual OpEx and improvements for our processes? As far as the energy storage landscape goes for BASF as a company, we're at several steps in value chain, right? So we have offerings for the e-mobility sector, right? So this is going to look like cathode active materials, not only through lithium ion, right? But we also have, a lot of R&D into these technologies. And at another point in the value chain, battery materials recycling, right? So they have a pilot scale facility that they've just started in Schwarzheide, Germany, right? So this is something that we're obviously looking at, and is how to not only improve these technologies, but how to recycle these components, these rare earth materials, in order to be able to utilize them again in the future to be more sustainable, right? That's the goal. As far as stationary energies go, so that was e-mobility, this is stationary. We're looking at the sodium sulfur technology, right? So NAS batteries. And we have partnered with another company, NGK Insulators, out of Japan, who has a lot of manufacturing expertise in these ceramics, these batteries. They have also a 20-year track record of installing these batteries in field in all regions of the world. So that's incredible, especially when you're thinking about a battery that's, this mid to long-term duration sweet spot of that 6 to 12 hour discharge duration. So what is BASF bringing to the table? Well, we have the global sales network where we can really access all these different regions. And we have the R&D and innovation ability to contribute in these areas to really fine-tune and improve the battery as is and offering to the customers and what they need. All right. So when you're talking about batteries, what do you care about? We get questions of, okay, what's your discharge duration, right? That really helps you narrow down, what do I need? Do I need 4 hours? Okay, I go with lithium. If I need 6 hours plus, I need something else. It's really going to partner well with a lot of these different applications. Okay, so how long is it going to last, right? doing a lot of work to qualify these technologies. I want it to last. So this is a 20-year system. It's really 7,300 cycles because it doesn't, experience calendaric aging. There's no depth of discharge issues with this. We can go 0 to 100 without impacting the lifetime of the battery. These are really good, important factors when you're looking at battery or energy storage. You want it to be safe. You want it to be reliable. This is really key. So you've got, okay, gas off, potentially toxic off gases from a lot of batteries. You have to, include firewalls. You don't want it to catch on fire, right? These are the things that we want to look at. Also, where are the raw materials coming from? Am I having to look at, mining practices that are sustainable or ethical? Then the sodium battery takes that out of consideration, right? Because these are readily available, abundant raw materials that are found in every area of the world, right? So this is really important as well. You want an energy dense system, right? You don't want it to take up too much space. That's not very sustainable. And you also want something that's easy to maintain. If it is in the field for 20, 30 years, we don't want to have to be changing them out or augmenting them, so frequently. So these are all things that we like to consider when we talk about batteries and improving the technologies. All right. When we're talking reliable with energy storage, you want to, this is not a, how do I say, it's a very conservative market, right? These are multi-million-dollar projects. People don't always want to try the newest, hottest thing. And so you want something that's really safe, really reliable, and you know that it works, right? So one of the things that was very attractive of partnering with NGK was that they have this, right? They've got almost 5 gigawatt hours installed globally, over 250 projects, right? And these are pretty large installations. You'll see, I think I show it in a later slide, a 50 megawatt, 300 megawatt hour installation and about 100 by 140 meters, right? So these are pretty small footprints, very compact little systems, but you're getting a lot of bang for your buck, if you will. All right. You also want to think, all right, I've approved a technology. A lot of, operators, developers are looking at this and they're like, that took forever. I want to be able to use it at all of my plants across across my pipeline on all of my projects within that discharge duration, right? So having said that, you want a system that is, applicable to all these different types of applications that you encounter in the market, right? How do you make money with these batteries? Are we looking at grid solutions? Are we looking at microgrids in rural areas and improving power to those types of off-grid applications? What do we need technically? What do we need economically? You want to make sure that you've got a system that will meet all of those. All right. So you might be wondering, okay, this is great. What's inside these pretty little shipping containers? We have a system that has 6 modules, right? 1.45 megawatt hours. I think I can actually scroll down with this. This will give you the numbers. 1.45 megawatt hours for each container. You're typically going to be able to double stack these, right? Which is really attractive when you're talking small footprints, okay? Double stack, put them in quads of 4. It's going to be about a 20 by 20 concrete slab for that energy density that you're getting. What's inside the module, right? One step back, 192 actual battery cells containing sodium, sulfur, and ceramic separated, right? So this is what we're looking at. This is going to be a hot battery. 300 degrees C is what we're targeting for a safe operating temperature, right? Again, it likes to cycle every day. It's kind of like the Southwest business model. You only make money when you fly the plane. You only make money from the battery when you're using it, right? So this likes to cycle every day. Go ahead, cycle it. If you do that, it's an exothermic discharge, reaction. This is going to keep your battery at temperature, and you don't have to turn on the auxiliary heaters. This improves then your round trip efficiency. That's how you maximize it. You just use it. So these are the things that we talk about that have really created a solid, reliable offer here. It's safe. We talked about this. These are some of the testing protocols that went into, the improved advanced system, right? You can essentially set it on fire. You can submerge it in water for 3 days, and you can drop it from 1 or 2 meters high, and we experience no cell leakage, no gas leak, and no thermal runaway, so no fires created there from that. So it's some pretty stringent testing. We also are seeing a lot more as the number of installations for batteries in this landscape are increasing. We see quite a few logistical questions. How do I get a 20-ton battery or a 50-ton battery to the middle of nowhere in Texas, or California, or wherever this is, right? That's on a dirt road at the end of the street. It's really something that we're coming up with a lot more questions about. So we really need to be mindful. How are we managing this? And this is something with the containerized solutions we've taken into account, right? You can put it on a ship, you can put it on a truck. It's an easy install with a crane. You drop in, plug and play, and you're ready to go. Right. When I just want to do a quick double check on time. I don't want to run over. You give me a thumbs up for, this number, Christina. Perfect.
You're good.
Again,
You're good.
thank you so much. Abundant raw materials are really important because not only for technological reasons, right? But also supply chain, right? We're seeing the curve, we're at this pivotal point where the energy storage is really increasing and we're going to be running short on lithium. What are we going to do, right? So how are we going to offer this? We need abundant raw materials that are going into these systems. That also keeps your fluctuations in price down. So just something to consider. For the installation example that I was talking about earlier, this is just a picture of kind of the footprint, how much space it's going to take up. This, just a note for all you, planners out there. This was about a 6-month installation period, so not a huge amount of time when you're considering over 250 containers coming in and out of site and being commissioned. So the key takeaways that I really want to leave with you, and I'm sure you have questions. I hope you have questions. If I can't answer them today, we'll get back to you. But we want something that's reliable. We want it to be safe. We're putting these into, to residential areas now. It's not just, a system in the middle of nowhere anymore. These are connecting into our grids. We want to be safe. We want to be thoughtful with it. We want to be sustainably minded, right? So we want to use raw materials that we have, that we're not mining for. And we want something that's low maintenance and easy to maintain for the next 20, 30 years, right? So that we don't have to keep repeating the same projects. We can move on and do bigger and better things. So thank you so much for letting me speak. Hope you learned something, and looking forward to your questions.
Thank you, Caroline. Perfect. Well, moving on to Alyssa, while Alyssa shares her screen. As Caroline said, feel free to ask any questions you may have. There were some questions about if the webinar was going to be sent to you and if we're going to share the presentations. Yes, we will in a couple of days. So Alyssa, I see that you are all set. Whenever you're ready.
All right, thank you so much, Christina. So as we mentioned in the intros, I'm Dr. Alyssa McQuilling. I'm the Research and Innovation Manager at the Consortium for Battery Innovation, and I've been there since 2022. But prior to that, I was at Southern Research in Birmingham, Alabama, where I worked at their energy storage testing facilities. So I had my hands on testing a site-use EV battery energy storage system and also a grid-tied flow battery system. So now at CBI, I'm working in collaboration with the lead battery industry. So I've had the experience of being able to work with a number of different technologies. And it was great to hear from Caroline on the role of having a diverse technology suite to address so many of the energy challenges that we face. So I work for a research nonprofit. So I'm going to take a little bit of time to talk about who CBI is and what we do. And also a couple of the big projects that we have going on currently or recently concluded to give everybody a flavor of what we do. So let's see. So CBI kind of works in four main areas. The primary area as a research nonprofit is to work with our member companies on improving lead batteries. So this facilitates improvements in technology in the battery and systems performance. So we have internally funded research that our member companies sponsor. So we have focuses on things like auxiliary automotive performance and energy storage systems and the role that lead batteries can play in those areas. We're also highly involved on the testing and standards development side of things to make sure that as we come out with standards and test protocols to validate the performance of different systems and make sure that everything operates safely, that the protocols are written with lead batteries in mind, that they're accessible, and that we're kind of capturing all of the unique characteristics of that as well. Another piece of what we do is on the comms and marketing side. So we have a team that is focused on showing how, while lead batteries have been around since the 1850s, they can also be a technology for the future. So we have on our website a number of case studies and videos, as well as an interactive map demonstrating where lead battery systems are in use today. And so we're also at conferences and exhibitions to kind of share our unique perspective. And then the role that I am most involved with is in helping our stakeholders secure external investments for their battery projects. So we have teams both here in the United States and in Europe, and they have work both in Europe as well as Africa and in South Asia as well. And so we'll get into some of the specific projects that we're working on a little bit later on in the presentation, specifically the ones that I have worked on here in the United States. So to summarize what was on the last slide, the goal of CBI is to increase the speed of lead battery research, to increase government partnerships and leverage kind of the knowledge that we have as an industry, and also change lead battery perception. There's a lot of things that lead batteries are good at, and kind of lessons that can be shared across the energy space, including particularly around sustainability and end of life. So lead batteries are one of the most recycled consumer products out there at a recycling rate of upwards of 99%. So our members, as I mentioned, are distributed globally. So the bulk of them are in the US and North America and Europe, but we have growing membership, particularly in South Asia. And our members kind of run the range from battery manufacturers across the supply chain. We also have lead producers, end users, and our research partners. And here, just a sampling of some of the partners, members and partners that we have. So this includes several of the largest lead battery manufacturers, which also produce lithium-ion batteries, some of them. So folks like C&D, Enersys, Crown, Stryten, Trojan, and East Penn, among others. And then in addition to our members who pay dues annually to be a part of our research programs, we also have CBI partners, and these are folks that are fall more on the end user side of things, or other non-governmental organizations, as well as universities and research facilities that we collaborate with on a range of both internally funded projects and externally funded research efforts. And just to kind of plug for our organization a little bit, we're always looking for more opportunities to collaborate and to get involved with research programs. And so if anybody has any questions regarding any of that, my email will be at the end of the presentation, and I look forward to hearing from you guys. Shifting gears a little bit, I wanted to talk about some of the recent projects that we've worked on. So the first is our U.S. military microgrid project. This was funded by the Construction Engineering Research Lab and the Army Corps of Engineers. Lead battery producers, so Advanced Battery Concepts, Enersys, East Penn, collaborated with Paragon Solutions at EAI and CBI to create a tactical microgrid for Fort Leonard Wood. This is aligned with the goal of the U.S. military and Department of Defense to have their installations be able to go off grid for a period of time, upwards of 2 weeks. And one of those solutions for that is to have a microgrid. So one of the key aspects of this project was understanding how to design a system that is rugged and durable and has, as Caroline mentioned, it's important to have things that are readily available in your batteries, or have batteries that are readily available. And the military is very familiar with lead batteries historically. So it was a great opportunity for partnership and collaboration between the companies within our organization and across the industry with a federal agency. Our most recent kind of newest project came out of funding from Storage Innovations 2030, the Technology Liftoff Program. So the idea is that the program was designed to foster partnerships between companies and research institutions to enhance the ability of different battery and storage technologies to get to the Earthshot goal of 5 cents per kilowatt hour for levelized cost of storage by 2030. So we were part of one of the 3 projects that were funded under this funding opportunity in collaboration with Battery Council International, which is the prime on the project. And we're going to be relying heavily on our 3 national lab partners, so Argonne, Oak Ridge, and Pacific Northwest National Laboratory. And then again, we have cost share commitments from 8 different US-based battery manufacturers, which account for roughly 90% of the US lead battery production. So really strong industry involvement. And the goal being that we'll investigate both current lead battery performance through a range of testing and modeling, and with the goal of improving lead battery performance to get to those cost and performance goals outlined by the storage liftoff reports. Getting into that, back in 2022 and 2023, the Department of Energy put out what they called storage liftoff reports for a variety of different technologies and chemistries. And within the lead battery report, they called out different areas where they felt like research investment could really improve lead battery performance for long duration energy storage. And in particular, the idea is to improve performance, which relatively lowers the levelized cost of storage, because you can cycle it more without having to augment or anything like that. So one of the kind of key areas that they wanted more research on was to better understand use case and duty cycle definitions, to better understand performance degradation and what that looks like kind of at the atomic scale for these batteries, and use that to design more efficient and robust electrodes and improve materials and energy utilization within the battery. And so the kind of overarching goal for the lead battery community is to raise this curve on the right. And the curve, if we raise the curve, that would mean that we can achieve greater depths of discharge with our batteries while also maintaining the number of cycles. So achieving that kind of durability and long life that is desired for these kind of large scale projects going forward. So specifically within the project, we have 4 research areas to achieve these long duration energy storage goals. So we're going to be testing our lead batteries, a range of lead batteries contributed by our partner organizations under LDA's load profiles at Pacific Northwest National Labs. We're going to be doing atomic scale analysis at Argonne National Lab at the advanced photon source to drive kind of better understandings of degradation in situ on these battery electrodes, and then leverage the expertise of Andrew Stack and his group at Oak Ridge National Laboratory to understand how lead crystal structures impact performance, utilizing kind of his existing knowledge of barium sulfate and its chemistry. And then finally using all of this information in collaboration with PNNL and ANL to kind of conduct some techno-economic modeling for how lead batteries can best serve kind of the LDS goals that have been set out by DOE. And none of this would be possible without the in-kind efforts of our industry partners. And so they're going to be helping procure samples for testing at the grid storage launch pad facility at PNNL. And then they're also going to be doing testing on their own products at their own sites according to the LDA's protocols that we come up with. helping with battery teardown for analysis at Oak Ridge and at Argonne, and then providing feedback throughout the process to make sure that the outcomes that we achieve in our efforts are both improving the performance of the batteries, but are also technically feasible for these companies to implement kind of in the near term. And so we're really excited about this effort and the efforts to find a space for lead batteries in LDES and improve their performance going forward. So with that, I'm going to thank you for the time today. And if you have any questions, feel free to reach out to me at alyssa.mcquilling@batteryinnovation.org or visit our website, which is batteryinnovation.org. And I look forward to kind of answering some of your questions as well.
Thanks, Alyssa, for that presentation. Moving on, we have Brett. Brett, whenever you're ready, you can start sharing your slides. And I have to say thank you so much to everyone for the questions that I see that Caroline is working on, and Sherif is also managing them as well. So Brett, I see your slides perfectly. The floor is yours.
Wonderful. Thank you so much, Christina. Hi, everyone. As I mentioned earlier, my name is Brett Simon, and I work for a company called e-Zinc. So I want to share a little bit about our company and our technology with you here today. So quick overview of e-Zinc as a company. Our company is headquartered in Toronto, Canada, though I myself am based out of our US arm, which is in Parsippany, New Jersey. We were founded in 2013, and we have roughly 70 employees across both full-time and consultants. We've raised over $75 million in private financing. That also includes our recently completed Series A2, which I'm sure a lot of folks in the audience saw news about. We've also been awarded $18 million in non-dilutive grants from government agencies. We have 7 patent families with international coverage, and we've done 1 field pilot to date, which was paired with solar at a compressed natural gas facility in the Toronto area to test out how our battery can cycle on a daily basis. We have 2 more projects that we've publicly announced that have been secured for the 2025-2026 timeframe. One of those will be in California with the California Energy Commission, and the other one will be with one of our investors, Toyota Tsusho, which will be deployed at one of their North American facilities. So I won't spend too much time on this because I think probably most of the audience understands the paradigm that we're in. We are in a very unique position where renewable growth is increasing massively, though simultaneously we have to increasingly deal with the high levels of variable renewable energy coming onto the grid. A study by McKinsey and the LDES Council found that once you hit the threshold of 60 to 70% renewable energy on the grid, that 8+ hour long duration energy storage becomes mandatory for the efficient function of the grid. And we're already seeing this being hit in certain localities in places like Hawaii, California, Texas, and that this paradigm is only going to increase in frequency as we move forward through time, as states and businesses and local municipalities continue to push toward a heavy renewable and carbon-free future. So I want to take a little bit of time to talk about e-Zinc's solution specifically. I have a little video here that I'm going to show you, and I'm going to periodically pause it as I talk through so you can understand how our battery functions. So e-Zinc's battery is what we call a hybrid flow battery. So we're not a flow battery in the sense of having the standard 2 separate tanks that have electrolyte pumped through them. Instead, we have a single cell, which is about the size of an aquarium that you would have for fish. And in this, we have zinc in a KOH electrolyte. So we have 3 sections of the battery: the charging section at the top, the discharging section at the bottom, and the storage section in the middle. So when this battery is actually charging, when energy is coming in either from the grid or from paired renewables, we actually have these zinc pellets that are going to be falling down through the battery cell. They're about each individually the size of a blackberry. And those pieces collect on the bottom of our cell. And when we wish to discharge the battery, we have an air cathode at the cell's base that we use to pump air into the system. You'll see that there in a second as we pump air through to discharge electricity. And this causes the zinc to go back into the electrolyte, and then it can be used going forward into the future. This creates a cell that is very robust, has low degradation, and high performance. Now, there's a lot of advantages to this solution, one of the first being low capital cost. We also have the ability to decouple energy from power. We can increase the size of our tank, and that can then therefore increase the duration of our system. Our system can dispatch anywhere from 10 hours at the lowest end to 100 hours at the highest end. Secondly, we have a flexible and scalable solution. We are able to serve anywhere from the kilowatt scale all the way up to hundreds of megawatts of scale. This allows us to be deployed for a variety of different customer types and market segments, which I'll talk about here in a moment. Our battery has a number of competitive advantages. I mentioned earlier our low degradation, which allows us to have a very long lifetime. We expect an over 15-year lifetime with minimal degradation. Our system can operate in a very wide temperature range, anything from -10°C to 45°C. This makes us a great solution, not just for your standard North American solutions, but also for off-grid solutions in very harsh environments, places like the Middle East, Sub-Saharan Africa, the Arctic, and so on. We are an inherently fire-safe solution. We have a non-flammable electrolyte, and we have no risk of thermal runaway, and our system has been designed toward UL certifications, and we are working toward obtaining them. And lastly, our system uses commodity materials, which allows for our system's components to be fully recyclable at end of life. So why would we choose zinc to be used for our battery? Well, there's two primary reasons. The first is that zinc has a lot of favorable electrochemical properties. It kind of sits right in the perfect middle of energy density, kinetics, reversibility, and stability, which makes it a great solution to be used for long-duration energy storage. Secondly, zinc is an abundant material, which means that it does not see the same commodity price fluctuations as some other different commodities. For example, if you look at this chart that I have here, you can see over the course of a few years how zinc has maintained a relatively stable pricing, while other components such as cobalt, vanadium, and especially lithium carbonate have seen very wide swings in their pricing, which makes the predictability of end project pricing very difficult to predict. Now I want to talk to you a little bit about the market opportunity of our system. So we are in a very interesting paradigm when it comes to energy storage. When you look at the very short duration solutions that can scale anywhere from the kilowatt to the hundreds of megawatt scale, you can see things like flywheels and capacitors that are very good at doing that. Similarly, if you're looking in this same scale in terms of power, but a slightly longer duration, up to about 4, maybe 6 hours, lithium-ion and flow batteries do an excellent job. However, if you want to go to a multi-day duration, really the only economic solutions today are pumped hydro and, in some unique cases, compressed air. However, those systems need to be built at very large megawatt scales. You can't deploy a system that's kind of in the single-digit megawatts or even the kilowatt scale, which makes them very inflexible for certain types of commercial, industrial, and mush customers. This creates this gap that you can see on the bottom right here of the chart. However, this is a perfect solution for e-Zinc. We have a system that can be deployed in the kilowatt to several megawatt scale, and that's going to be our initial focus, what we call our Horizon 1 and 2 markets. These are the CNI and mush type customers who need resilience, as well as some amount of daily cycling for bill management, as well as grid services. And additionally, customers who are remote. So these include remote industries such as upstream oil and gas, metals and mining, telecom, as well as remote communities that you can find in places like Canada or the Middle East. And longer term, we do expect to deploy our systems in this larger scale. We call that our Horizon 3 target. These will be the large scale utilities focused systems for things like bulk energy shifting and T&D deferral. So this is a quick look at the field demonstration project that I mentioned earlier. It's called the Fairmore project. We deployed it in Woodstock, Ontario to look at daily cycling of our system paired with solar. We got some really exciting results from this and has helped us inform as we build out our commercial product. Just wanted to share also this last chart to just basically thank our investors and note to folks on the call who are some of the folks backing us. BDC, Anzu Partners, Toyota Ventures, Mitsubishi, Energy Foundry, EVOC Innovations, Eni, and EDC all have been integral in the growth of e-Zinc to date, and we look forward to continued growth in the future. So with that, I believe I'm at time, so I will say thank you, and I look forward to taking your questions.
Perfect. Well, thank you so much, Brett. Yes, you perfectly on time. So thank you so much, the three of you, for these amazing presentations and getting to know more about batteries and their use. And it's, as we can see, not every technology fits for everything. So without further ado, I'm going to leave the floor to Sherif, who's been already managing the questions. So Sherif, whenever you're ready, we can start with a discussion.
Perfect. Well, first of all, thank you for Alyssa, Brett, and Caroline for the amazing presentations. I've really learned a lot, so thank you again. We received a ton of amazing questions. I'll kick things off with this one because it's a source of a lot of confusion for folks. For each of you, how do you define long duration in the long duration energy storage technologies? Everyone seems to have a different number for the hour duration. Recently I've seen a lot of terms being thrown around about medium duration, long duration. So for our purpose here, what is long duration for you?
I can take a first stab at that, Sherif. So in my view, it's best to probably align to an agreed upon metric for long duration. And I think the US DOE has done a really good job of defining that. So they really break long duration into, I believe it's 3 categories. So the first category is 10 to 36 hours. They call that interday. These are really your systems that are going to be shifting energy within a single day or maybe a little bit more than one day. Then they talk about multi-day, which is 36 to 160 hours. These are solutions that can store energy and deal with more of kind of the daily or even weekly fluctuations that occur. And lastly, they have what's called seasonal storage, which is anything above 160 hour. Those are for the kind of massive shortfalls that you might expect as renewable energy clocks up into the 90s or 100 or even 100% of grid electricity. So I think that's a very good way to define it and an easy way to see kind of how the different long duration technologies fit into the full picture.
Okay. Right.
And to add to that, one thing, different metrics become more or less important depending on how frequently you're cycling. So for those kind of seasonal storage opportunities, if you're not losing as much efficiency because you're not cycling as frequently. So taking that energy hit, you're only getting it once. So different metrics become more important depending on what you're trying to do at what time scale.
100% agree.
Yeah,
Caroline?
and yes, I appreciate that those comments, Alyssa, because for us, it's what does the customer consider to be long duration, and we want it to be a good economic fit for them. We want this to make sense for you, and it makes sense for you when you cycle these batteries every day, typically, right? So if you don't need multi-day, then this is a good fit. And what we've seen, and I put this over in the questions, the Q&A session, it's kind of like that 6 hour for us seems to be a kind of a break where we start to see an economic benefit from transitioning away from lithium to another technology. But it just depends on what you're trying to do, like Alyssa said. So I think welcome to the dynamic world of energy storage, right? Because we're creating these definitions as we go through it, as the technologies improve, and as we define what makes sense for each and every different application use case.
That is an amazing segue to this next question here, and I 100% agree on both your points on the importance of the use case and what exactly kind of the user is trying to do. So at Storlytics, we're really big on benchmarking technologies and finding kind of the optimal use case for each energy storage technology. So for you all, what is your silver bullet use case for your technology, the type of usage that you wish all of your prospective clients knew. Brett, you mentioned some really good applications in your presentation: backup power, remote microgrids. Alyssa and Caroline, and Alyssa, I'm going to ask you as a representative of lead acid batteries, since CBI is so big on lead acid batteries. But go ahead, take the floor.
Sure. So one of the areas that we see a lot of opportunities as EVs kind of replace internal combustion engines, moving away from the lead batteries in vehicles, is to get into the energy storage space. And one of the areas that we think is a really solid opportunity is in EV charging backup. Given the transition to EV charging, there's going to be demands for kind of large amounts of power, maybe at the end of a power line. And so to accommodate kind of the growth of the EVs and their demands for power for charging, we see it as an opportunity to insulate customers from demand response charges. And then additionally, we're seeing a lot of opportunities around residential energy storage systems for home backup in a variety of different markets, particularly in South Asia. And we're also seeing kind of large grid scale opportunities. And we've seen some evidence of that in China. We know of a project that is over 100 megawatt hours at 10 hours duration. So I think there's a lot of growing opportunities and excitement around lead batteries as we continue to do research and improve its performance as it transitions out of kind of the traditional role that people have seen it in.
Caroline?
Yeah, so for the NAS battery, for the sodium sulfur system, I like the versatility of this product and this technology. But if I had to pick one that I think is very sustainable for the future, it's to couple it with renewables on utility scale where it cycles every day and it makes good economic sense, and we can support the grid, we can do the time of use shifts to meet the demands when we need it. I think this is really where this system makes a lot of sense because it helps you get 24/7 storage coupled with renewables for the large scale utilities.
Perfect. All right. Really appreciate those responses. Alyssa, kind of back to you. I got a very a great question here from Mark Kamenzai. So lead is obviously toxic and can contaminate millions of gallons of water. Should we have restrictions to prevent siting near oceans, lakes, floodplains, tsunami zones, and other kind of prone areas?
I think this is true regardless of kind of the battery chemistry. I think we need to design the systems with safety in mind at the start. I don't think it can be an afterthought for any of these systems. I do think that there's kind of opportunities for secondary containment, making sure that where you're siting is not in a floodplain. But I think a lot of the existing expectations and standards around siting of energy projects is applicable to lead batteries, just like any other storage technology. But it is something that I think the lead industry is exceedingly aware of and recognizes historically that it's not something that has always been handled perfectly. And so I think it's in the industry's interest to be as mindful as possible and design with safety in mind, secondary and tertiary containment where possible, and siting appropriately. Absolutely.
Perfect. All right. I have another question here. So I think, Brett, this one is for you. What is the general round trip efficiency of e-Zinc's battery technology?
Yeah, so the short answer is I can't answer that without a MNDA. We're a privately held company and we don't publish our specifications publicly as of yet. What I can tell you is that it is significantly lower than lithium ion. But as Alyssa very eloquently pointed out earlier, the longer duration you go, the less round trip efficiency tends to matter because you're not cycling in the same way. You have some lithium batteries that are used for things like frequency regulation that might cycle even twice a day for a full cycle if they're a 2-hour battery. But then in our case, if we're looking at a 24 or 100-hour battery, that battery isn't always going to be fully cycling. Sometimes that battery is going to have some reserve for resilience purposes, for example.
That's a very good point, Brett, and I'm very happy you touched on it. And it goes back to the point that Alyssa and Caroline made about the importance of the use case, right? So if you have a battery technology that is very high on self-discharge, right, but you are cycling heavy, in a heavy manner, such that you're not just leaving it to self-discharge, that characteristic might not be as important. Conversely, in your case, if your use case doesn't have a lot of cycling and you have a low round trip efficiency, it's not an impactful characteristic. So I appreciate you mentioning that. All right, great. Going down the questions list here. So, and this one is really for everyone. So one of the biggest challenges of new long duration energy storage technologies is competing with lithium as its pricing continues to go down. There's obviously ripple effects for that dollar per kWh figure that would render kind of lithium more and more suitable for longer duration, maybe not multi-day, but within the day. So how are you all planning to compete with lithium today? And not only that, but to be able to continue to compete with it in the future?
I mean, I think I'd give maybe a somewhat controversial answer that I don't think in most cases lithium is a direct competitor to us. There's a metaphor actually that I like to use a lot when I'm talking about this industry, which is the metaphor of tools, right? Every tool has its own use case. So for example, you wouldn't use a pocket knife to cut down a tree, but you wouldn't use a hatchet to cut a piece of fruit. So you have to think about what you're actually using the systems for, right? I mean, lithium today is topping out kind of around 6 hours, maybe 8 hours in an extreme case. And that's below our lower end of duration that we plan to serve. So people will ask us about lithium. We'll hear discussions about lithium when we talk with clients, but usually the context of the projects that actually need 10 or 24 or even 100 hours of storage aren't really considering lithium in a big way.
Perfect. Caroline, I'm going to go to you. Brett had a great response. I mean, their technology is at least 10 hours. You're in the 6 to 8 hours range. So
we are in that kind of sweet spot between. But I would give a similar answer to Brett. If you need a 2-hour battery, use lithium. It's not going to make economic sense. You're going to be, unless you have a real safety concern, or you need to put this in a very extreme climate, right, where the technology is not going to be appropriate for the location, the geographical location, the climate, and all those types of things, and you really need that. It's overkill to use one of these longer duration storage technologies for, I just need it to flip on when when the power's cut. That's not what we're doing here. And it's not going to be a good representation of what the technology can do or a financial use case. Even if, Brett's saying, or, we're looking at lower cost than lithium, it doesn't matter, right? So I think we need to be really sustainably minded about what we're doing with choosing the right technology for our application, for our need.
Makes sense. Perfect. All right. I think we have time for probably 2 more questions here. So this one, what is the duration on lead storage projects across regions you operate in? And Alyssa, I think this one's for you.
Yeah. So we actually on our website have an interactive map with case studies of different energy storage systems that are on the grid or have been deployed. And on there you can find systems ranging in scale kind of from like 15-minute UPS and frequency regulation type use cases all the way up to 8 to 10 hours. So there's a really wide range. I would say if I was going to pick the most common that is currently deployed, just based on kind of market forces, it's in that 2 to 4 hour window. But I think that there is a big push towards longer duration and just kind of being prepared. I think one of the things that when we're thinking about the grid of the future and energy storage, I think we can't be thinking about what we need today. I think we have to think about what we need in 10 years, 5, 10, 15 years, because infrastructure takes a long time to construct. And thinking about things ahead of time is where we would ideally like to be. And that includes things like thinking about end of life when you're installing, having that recycling and remanufacturing infrastructure in place and understanding what that looks like in terms of cost. And so I think there's a lot to be said for kind of planning ahead with that.
Okay. All right, next one here. What are the most difficult barriers to overcome towards market entry that long duration battery technologies face? And Caroline, I'll start with you.
Yeah, definitely. I think it's not necessarily about the technology. Obviously, 5 gigawatt hours installed should be enough to say, oh, we're in the market, but it's a mindset change. It is, we've been doing this, all of our, installers, our EPCs, our maintenance people understand lithium. Changing a mindset, even when I talk to very educated people and I tell them, they're like, well, let's do a use case of apples to apples to compare lithium to your system. Okay, great, let's do that. But they're like, you can only discharge to about 50%, battery capacity. I'm like, you're missing the point, right? So it's a mindset change of like, this is a core difference in the technologies, right? Use it like it's meant to be used, right? Do a 0 to 100% discharge. Then we can talk about what you actually need in terms of sizing, in terms of, your pricing and your containers and your augmentation schedules, right? This is, I think it's just, taking a deep breath and helping them see this is different doesn't mean bad, right? And so I think that's the struggle with getting into the market is it's just a different way of thinking about something that they've been doing for the last 30, 40 years, right? And it's not cheap. So, you don't want to make mistakes that aren't, $5 to $10, right? I've got a very low risk of profile, but this is something that we see.
Yeah, definitely the benchmarking part and going beyond just looking at RTE numbers and data sheets and cycle counts to, all right, these are the use cases. This is how one technology performs. This is how the other. This is how we excel for these 1, 2, 3 use cases. Getting that point across definitely is difficult. Brett, how does e-Zinc deal with that?
Yeah, I mean, I think it's a great question, Sherif, because, and I think Caroline outlined it excellently. So we're in a paradigm where LDES is not properly valued for the services it can provide by basically any market in existence today, anywhere in the world. And a lot of that is because the technology class is relatively new. I mean, I even think about back when I first got in this industry in 2015, even then, 4-hour storage wasn't fully valued for a lot of the services it could provide. And it took in the US, which is my main focus and my main knowledge base, there was a lot of effort that had to be made even for rules for storage to participate in ISO markets, to be properly compensated for the services it provided. And LDES needs to go through that too. The thing that's encouraging to me is that there are a lot of very smart folks working very hard on this. The DOE has a number of Tiger teams that are working through and talking through how to make policy structures and market reforms to really bring this forward. A lot of different states are building out incentive programs and pilot programs to understand and support LDES. And this is all very encouraging. It's not going to be overnight. It's going to take many years, but I'm confident that the structures, the efforts we make now will put the structures in place over the next decade for these technologies to really flourish.
Yep. Well said. All right. Well, we are at 1 p.m. exactly, and so Christina, I'll pass it over to you.
All right. Well, thank you so much for that excellent moderation. I have to say, Sherif, are you free for the next webinars that we have for the next year? Just let me know. But thank you so much for that excellent moderation, as well as the speakers. Very clear. I agree, Caroline. It's a change of mindset. It's a change of idea. It's kind of looking at a different perspective. And I have to say, Brett, that example about lithium ion, I'm taking it to use it because it was an excellent example. And thank you so much, everyone, for starting this conversation. We have more conversations ready at our event on the 25th and 26th of September. We hope to see everyone there. And we also have more webinars in sight, so please stay tuned. I think for the next one, I will be moderating. It won't be Sherif, unfortunately, unless he wants to and he's available. Just kidding. We're just kidding. But thank you so much, everyone, for joining today. And we hope to see everyone very, very soon. So I hope you all have a great day.
Thanks,
Thank
everyone.
you all.
Thank you. Bye.
Thanks.